All right, welcome back, everyone. Today we're going to be looking at a few practice problems with binomial expansion. Um, I believe I said we were doing binomial theorem yesterday. I must correct myself. Binomial theorem is basically a step ahead of where we're at right now. We're using Pascal's triangle to expand. Binomial theorem uses it's called combinatorics, or it's called combinations, to kind of shorten the process or make it go a little bit faster than what we're doing. So if you end up taking future math classes, that might be something you cover. But what we're looking at works exactly for what we want. Remember, what we're doing with this Pascal triangle is expanding binomials instead of having to like multiply them out and FOIL. This usually can save a bit of time. So given here is Pascal's triangle. I mean, you could always kind of write it yourself, or you could just Google it. But keep in mind when you label this, like you label the rows and you start with 0. And we're going to see we use these different rows depending on what the power of our binomial is. And you can see, I mean, it does get pretty crazy even when you get higher power. So even with this shortcut I'm teaching you, if you had a binomial up to like the 7th power, I mean, it's a pain. I won't lie to you. But I've got 4 problems we're going to look at. So this first one, we have 2m minus 1 up to the 4th power. So the first thing you want to look at, it's the 4th power. So we're looking at this n equals 4th row. Or really it would be the 5th row down, because remember, you start at 0 when you label these rows. So the first thing I like to do is we're going to write these coefficients from Pascal's triangle, and after each coefficient we put 2 sets of parentheses. So like 1, we have a 4, we have a 6, we have another 4, and we have a 1. Okay, and what goes inside our parentheses is basically like the first part of your binomial and then the second part. So we're going to have 2m, and then we're going to have minus 1. So basically a -1 since it's a minus. And that's what's going to go inside all these parentheses. Okay, and then our powers. So with your powers, your first part of your parentheses always starts as the same as your binomial. So it starts as a 4, and then it goes down by 1 each time. So it goes to 3, it goes to 2, it goes to 1, it goes down to 0. And then the powers for your second parenthesis, it starts at 0 and it goes up by 1 each time, all the way up to 4. And you should see that your powers always add up to your original exponent, which in this problem would be 4. Like, so if for some reason you get something like it's not adding to what you started with, I mean, maybe you messed up, maybe you skipped a spot or something weird like that happened. But from here, we just really need to clean this up. So my advice is just focus on the number parts first. So we have a 1, we have a 2 up to the 4th. So 2 up to the 4th, if you put that in a calculator, if you do it mentally, 2 times 2 is 4, times 2 would be 8, times 2 would be 16. And then we have -1 up to the 0 power. Remember, anything up to the 0 power is just 1. So we would have 16m to the 4th. Like, that's what that would simplify all the way down to. Now we want to do our next part. We have a 4. We have a 2 up to the 3rd power. 2 times 2 times 2 would be 8. And -1 up to the 1st power stays as -1. So if you multiply that all out, 4 times 8 is 32, times -1 would be a -32. So we're going to have a minus. And then our m would be up to the 3rd power. So continue on with this process. We have a 6. We have a 2 squared. So that's a 4. And -1 up to the 2nd power, remember, that's going to turn into a +1. So if you multiply that all out, that's going to be a +24. Then if you look at your variable part, sorry, that would be m to the 2nd power. Okay, now we got to clean up the next part. So we have a 4, we have a 2 to the 1st power, so that stays a 2. -1 up to the third power. Remember, if it's an odd power, it keeps your sign. So that would be a -1 still. If it's even, it would turn it into a positive. But if you have a negative number up to an odd power, it's going to stay negative. So this would be a -8 when we're all said and done. And if we look, our variable would just be up to the first power. So it's just going to be an m. And you can kind of see, I mean, your degrees are going to be dropping each time. At least for your first part, if it was in your second, if your variable's in your first set of parentheses, you would see if your variable was in the second set of parentheses, it would actually be the reverse. Um, but looking at our next part, we have sorry, I got a little bit sloppy. We have 1 and 2m up to the 0, so that just turns into a 1. And then we have -1 up to the fourth. Remember, it's an even power, so it's going to turn positive. And I mean, 1 times 1 times 1 times 1. I mean, that's just going to be 1. So honestly, all that's going to do is give us a +1. And our variable part actually went away because m up to the 0 turned into a 1. So this would be our final answer. And you might debate me, but I would argue that that is much faster than having to FOIL this out. Maybe if you're like the world's fastest foiler or multiplier, maybe that is faster. I'm not sure. But personally, and there are ways to speed up this binomial expansion process. Like I said, if you do end up taking, like, you study a lot more math classes, you'll learn more about binomial theorem, which basically it's kind of a shortcut to do the coefficient part using combinatorics. Probably won't be something I show in this class, but there are ways to kind of work and make this even better than what I'm showing you right now. But this is a good starting point for kind of our knowledge base right now. So that's our first problem. Let's look at another one. And I hope this video is helpful. But please, if you need help, try and stop in or ask questions. But for our next part, we have x minus 1 up to the third power. So since it's the third power, we're looking at our n equals 3 row, or really it would be the fourth row down. In that YouTube video I shared, the lady mentioned that whatever your power is, you're going to have one more term than that. So like, since it's the third power, you should be looking for the row that has 4 coefficients. And that's another kind of trick or kind of way to remember it possibly. But like I said, I like to write my coefficients and put my sets of parentheses. So I have a 1, I have a 3, I have another 3, and I have a 1. What goes inside these parentheses, remember, like the first part of your binomial goes in the first parentheses, and then the second part of your binomial goes in the second part. So it would be a -1 because it's a -1 in that formula. Okay, so we'll just copy that into all of these. Oh, I messed up. I reversed it there. Oopsies. I think I would have caught that, but glad I caught it before we went too far in the process. And then we got to do our powers. So remember, your first parentheses, the power starts with your original, and it goes down by 1 each time until it hits 0. And then your second set of parentheses, the power starts at 0 and goes up until it hits your original power, which in this problem would be 3. So this is like, we got it set up. Now we just got to kind of clean this up a little bit. So first, in this first part, I mean, you're just going to have 1. I mean, there's no coefficient, so I mean, that's just going to be a 1, and -1 up to the 0 power is still 1. So this would just be 1x cubed, if you kind of simplify that all the way out. For our next part, we just have a 3. We have an x squared. So I mean, there's really no number part there. And then -1 up to the first power would be -1. So this would be a -3. And then our variable part would be x to the second power. So this one is not too bad to simplify since you don't really have a coefficient with your variable. But for this next part, we have a 3. I mean, there's no real number part inside this piece, so we don't really have to worry about that. -1 up to the second power would be +1. So this is going to be a +3. And our variable part would just be x to the first, or just x. And then our last part, we have a 1, x up to the 0 is just going to be 1. And then -1 up to the third would be -1. Because remember, that would really be -1 times -1 would be +1 times another -1 would give us that -1. So this would be our answer. But we've got a couple more. And if you need more practice, let me know. I mean, I could probably find some more problems. I just kind of pulled these off of a worksheet I found online. Um, but keep in mind, like these problems I'm showing you here, if you notice the powers are like between 3, 4, and 5, like that's what you would see on your test on Friday, and you'll see that on the review. I'm not going to give you any powers that are bigger because obviously the bigger your power, the more coefficients or more pieces you're going to have to work with. So I'll try and keep it pretty similar to these types of problems. So I just want to label my rows really quick. Okay. And we're not going to go any higher than that. So, so we're still, once again, we're looking at we have a third power. So we're looking at this same row as actually the last problem. So we have a 1, your parentheses, we have a 3, put your set of parentheses, we have another 3, put your set of parentheses, and we have a final 1, put your set of parentheses. So like I said, remember your first part of your binomial goes inside the first set. Your second part goes in your second set of parentheses, if that makes any sense. And since it's a +3, it's going to be a +3 when we put it in. So for our exponents, remember your first set of parentheses, you start with your original power and it goes down by 1 each time until it hits 0. And then for our second set of parentheses, it starts at 0 and it goes up until it hits your power. Basically, they're kind of the reverse of each other, if that makes sense. So we want to just clean this up and we'll be done with this question. So I like to kind of just deal with the number parts. That's going to be a 1, 3 up to the 0 is going to be 1, 4 up to the third power, that would be 4 times 4 is 16, times 4, that would be 64. So I mean, all together, we're going to have 64. And don't forget about your variable part. That would be n up to the third. All right, so we're good with that part. Our next piece, we have a 3. We have a 4 squared. That would be 16. We have another 3. So we got to multiply this out. So 3 times 3 is 9. 9 times 16 would be 90 plus 6 times 9 is 54. So it would be 144. Just make sure I'm right there with my math. That would be 48 times 3. So that would be 150 minus 6. Yep. Okay. We're good. And I apologize. If you do see a mistake in this video, I am doing this all in my head. So if I do make a goof, I apologize. I think I haven't. I don't think I have yet, I mean, but. So then 3 squared is 9. So we looked at all our number parts. So we got to multiply this out. So 3 times 12 is, 3 times 4 is 12, sorry, times 9. 9 times 10 is 90 plus 9 times 2, that would be 18. So that should be 108. Okay, and then for our last piece, that's a 1. 4 up to the 0 would also be 1. 3 to the third power, well, that would be 3 times 3 is 9, times 3 would be 27. So that would just be 27, and your variable part basically disappears because it's n up to the 0. So that's our final answer. And then I got one more problem, and this one decided to go a little bit crazy. We're going to do up to the 5th power. So, but this is as bad as would ever get. So the 5th power is this row, like the 1, 5, 10, 10, 5, 1 row. So we got a lot of pieces. So I'm going to try and make sure I don't write too big. We got a 1, 5, got a 10, another 10, got a 5, got a 1. All right. And we somehow managed to squeeze it in. Not perfect, but not terrible either. So remember, you're going to put your first part and your second part. Since it's a +4, it's going to be a +4. Oh, that's a 10, not a parentheses. It's getting all flustered. Okay, and as always, we start with our first set of parentheses. You start with your original power and it goes down by 1 until it hits 0. And for your second part, you start at 0 and you go up until you hit your power. Okay, and then we're almost there. We just got to clean this up. This first part, I mean, you're just going to have a 1, and I mean, that's going to really be a 1. So you're really just going to have a b to the 5th. For this part, luckily in this problem, we don't have a coefficient with a variable. That makes it a little bit easier. So I mean, 4 to the 1st is just 4. So you add that together, you get 20. This one, we got a 10. Got a 4 squared, so that's a 16. And like I said, it's really nice that we have a 1 here because we don't have to like deal with that coefficient number part. So 10 times 16 would be 160, and we'd have b to the 3rd. For this next part, we have a 10. We have a 4 to the 3rd. That would be 16 times 4. That would be 64, if I'm not mistaken, right? 4 times 4. 16 times 4. Yep, okay. Just double checking my math. So 10 times 64 would be 640. And our b would now be up to the second power. We got 5. We got 4 to the 4th. What would that be? 4 to basically it would be 16 times 16. What is that? Give me a second. I don't want to mess this up. I'm getting a little nervous with some of these. I'm pulling out my calculator. I'm giving in. I'm weak. But it would be 256. I can't believe I didn't know what 16 squared was off the top of my head. All right. I was just having a brain fart. I mean, I know 15 squared was 225. I should have. Oh well. All right. And then we got 1. Oh, geez, we got 4 to the 5th. I'm definitely just plugging this in. But you basically your b part's going to disappear, and 4 to the 5th power is 1024. And that would be your answer. And this is pretty cool. And like I said, there are ways to quicken up this process. Like instead of dealing with these sets of parentheses and trying to figure out your number, there's definitely some tricks with these that you would learn if you end up taking maybe you might say, I don't know if you'll do it in like your 1530 course, but definitely if you end up taking some like calculus level classes in college, if you're planning on being like a science or a math major, you'll definitely learn some tricks. But this is kind of like the bare bones way to do this. But there's some ways using, it's called combinations, to kind of quicken this. I mean, if you're interested, you could look up binomial theorem to kind of see if you're trying to see more about this. But this is what it's all going to be based on. But there are ways to kind of work on improving this. So I get like, because for example, like to be quite honest with you, if I asked you to expand b plus 2 up to the 10th power, that's going to be a pain in the ass. Excuse my language. I really shouldn't be swearing, but it really, but even with the shortcuts, I mean, like when it gets that big, it's going to be a pain any way you look at it. But there are definitely ways to improve on this method. But it's definitely a good kind of initial step. So I hope this video helped. Please stop in for tutoring, or please just email me if you have questions. If you're looking at maybe you made up an example and you're trying to see how to make it work, I will happily help you throughout the week or whenever I can. So have a good day, everyone.